scientists have discovered remnants of what appears to be another planet within the Earth. These remnants, resembling two giant stone spheres, are said to be as large as entire continents. Some scientists suggest these could be the remains of an alien planet named Theia. Roughly 30 to 40 years ago, while conducting earthquake studies, scientists accidentally stumbled upon these two enormous rock formations buried deep beneath America and the Pacific Ocean. These rocks are distinctly different from the ones found on Earth. The main question that arose was, how did these huge rocks manage to reach the Earth's core? At this point, a geophysicist named Qian Yuan from Caltech University made a bold claim that these are indeed remnants of an alien planet. Typically, when someone makes such a bold assertion, it is backed by solid evidence. This is how scientific methodology works to substantiate a theory. Additionally, the planet Theia, which these rocks are associated with, is hypothetical. So, I posed the question again, can we really trust their research? Moreover, how can such massive stones exist inside the Earth without disturbing its rotational stability? To be honest, whenever we delve into such topics, we encounter numerous myths, misconceptions, and rumors. We started from the very basics, the fundamentals. The story begins in the 1960s on the Hawaiian Islands, USA, where in just 3 years, about 8 volcanoes erupted. To solve this puzzle, scientists created a map of all active volcanic regions around the world. Thus, 2 conclusions emerge. First, something beneath Africa and the Pacific Ocean must be generating these hotspots. The only way to uncover this mystery was to find a way to penetrate the mantle. So, some US scientists proposed using earthquakes to explore the Earth's depths. However, the experiment yielded completely unexpected results. Upon closer investigation, they discovered 2 massive structures resembling sand dunes, located deep beneath Africa and the Pacific. Following this discovery, scientists named the blob under Africa Tuzo and the one under the Pacific Jason. The next step was to investigate the connection between these hotspots and the alien rocks. They suggested that around 200 million years ago, as the Pangaea supercontinent broke apart, the dense oceanic crust began to sink beneath the continental crust, eventually reaching the mantle. Due to extreme temperatures and pressures in the mantle, the water molecules in it came into contact with the iron in the core, turning it into iron peroxide. Because iron peroxide molecules are denser than lava, they accumulated at the boundary between the core and mantle. Over time, this led to the formation of 2 massive structures, blobs that retained dense materials like iron peroxide. When they became overloaded, this dense material broke through the crust and erupted as volcanic hotspots intermittently. By now, scientists had established 3 things. First, most hotspots are located in the African and Pacific regions. Second, there are 2 huge blobs beneath these hotspots. Third, these blobs are likely responsible for these hotspots. Now it was time to delve deeper. Ritsema and Hoffman's theory explained how these blobs could have formed. However, the theory did not address why these blobs formed specifically beneath Africa and the Pacific. Could they not have formed elsewhere? Many scientists at the time contemplated this question. They believed that if they could develop a theory that builds on existing knowledge, they could connect the dots. However, they didn't realize this line of thinking would lead them to a dead end. Scientists assumed that connecting hotspots to blobs would be as straightforward as linking blobs to Africa and the Pacific. But the theories proposed could not connect these 3 elements, hotspots, blobs, and Africa-Pacific, together cohesively. Finally, in 2021, a completely different theory surfaced, catching everyone's attention. This new theory proposed that these blobs are actually remnants of an alien planet named Theia. Supporting researchers claim to have proof for this. Let me explain. In 2021, a geophysicist from Caltech University, Qian Yuan, published a theory. According to him, about 4.5 billion years ago, the Earth was significantly smaller than it is today. Then, it collided with a massive planet called Theia, almost the size of Mars. This collision was so powerful that it caused 3 significant events. First, the Earth started rotating on its axis. Second, a large fragment of Theia broke off, forming our moon. And third, the remaining pieces of Theia got trapped inside the Earth. Yuan further proposed that after this massive collision, the Earth melted completely. Because Theia's density was higher than that of Earth, its fragments sank deeper into the Earth, reaching close to our core. Regarding their present location, an alternate study suggests that these blobs might have settled under Africa and the Pacific to help stabilize Earth's new, tilted rotation, positioning themselves directly opposite each other, much like the workings of a gyroscope. In a gyroscope, internal components adjust their movement to balance its rotation. So, does this mean the Theia theory has finally provided a comprehensive explanation that links hotspots, blobs, and the Africa-Pacific regions? Technically, yes. This theory explains where these blobs originated, why they are located specifically beneath Africa and the Pacific, and if we also integrate the oceanic crust subduction theory, it helps us understand why these hotspots form. Essentially, we now have answers to all the necessary questions. This leaves just one thing: proof. What concrete evidence is there to support this theory? Is there any proof that an alien planet like Theia ever existed? Qian Yuan and his team assert that they have evidence. They claim that when they ran a computer simulation to test their hypothesis, they created a planet with mass and chemical composition similar to that of the Moon, named Theia, and simulated its collision with Earth. The simulation results matched their hypothesis exactly. A large part of Theia did indeed become the Moon. Earth melted due to the impact, and Theia's remaining dense fragments made their way to the core mantle boundary of the Earth, just as we see in reality today. This implies that thanks to Yuan's theory, we might finally have a scientific answer for the origin of these blobs, and it could very well be correct. However, there's still a problem. Unfortunately, we have to treat this as a theory for now. Why? To substantiate their claim that these are remnants of Theia, the computer simulation Yuan developed relies on an educated guess of Theia's chemical composition. This is because we still lack comprehensive data on the Moon's full chemical composition. We only have some shallow soil samples from its surface. Given these circumstances, constructing a simulated model of Theia from this incomplete data introduces a potential margin of error. That said, we cannot entirely dismiss this idea either, because the simulated model does offer a reasonable explanation for the existence of these blobs. Yuan and his team are well aware of this limitation in their simulation, which is why they are currently awaiting lunar rock samples from NASA's Artemis mission. In the future, they hope to compare these samples with the blobs to determine if they are indeed pieces of Theia. This brings us to one final question. Even if the Artemis mission does bring back rock samples from the Moon, how exactly will Yuan compare these samples with the blobs buried deep in the Earth's mantle? This is the question that, to me, is the most exciting part of today's discussion, because Yuan's team plans to compare moon rock samples with the blobs. Since it is a future project, there is no clearly defined process available yet. We must speculate on what their approach might be. So before I share my thoughts, why don't you give it a try? If you have an idea, feel free to comment below and let me know. Now let's dive into the possible answer. You may recall that we discussed the subducted oceanic crust theory, which provides a link between the hotspots and the blobs. If we look closely, it states that these blobs, remaining in one place, allow isotopes, different variants of elements, to concentrate over time. Then when the mantle plume, essentially mantle lava, erupts from these hotspots, these isotopes get recycled, forming rocks of solidified lava. This means we don't need to dig all the way to the mantle to compare the rocks of the Moon and the blobs. Instead, we could collect solidified lava rocks, like basalt rocks, from active hotspots such as the Hawaiian Islands, and use them to determine the chemical composition of the blobs. From my perspective, science isn't just a subject, it's a way of thinking, a method, an approach, a lens through which we see the world, allowing us to feel exhilaration in every challenging situation and every solved problem. And once we find the answer, there is an immense sense of achievement. Moreover, this scientific approach is something we can apply to our own lives to solve our personal challenges. So friends, to watch such interesting videos, subscribe to the channel and press the bell icon and take care of yourself. Thanks for watching.